If we want to get an idea of how it is the galaxies actually formed, we're going to have to look at very, very distant objects. The idea is that the farther away we look, the farther back in time we are looking. So if we want to get to the early universe where galaxies are still forming, we have to look at very, very distant objects. And when we do, we don't actually see spirals and ellipticals like we do today. Instead, we see many small, dwarf, irregular galaxies that are relatively close together. We believe that several of these things merge together in time, and that then builds them larger into the size of the galaxies we see today. Now, once these things are big enough, what determines whether they turn into a spiral or an elliptical is going to be the star formation rate. If we have one of these protogalaxies that has a relatively slow star formation rate and high angular momentum, then because the star formation rate is slow, all of that interstellar medium is going to be able to continue to sink. But because it has a high angular momentum, it's going to start spinning faster and faster so that it all settles down into a nice disk. Well, because the disk has all of the interstellar medium, this is where we're going to continue star formation, and this will eventually lead to a spiral galaxy. So spiral galaxies had slow star formation rates and higher angular momentum. On the other hand, if we have a protogalaxy that is collapsing quickly and we have a really rapid star formation rate, then it's going to burn through all of that interstellar medium before it settles down into a disk, in which case we have this ball of stars that are all roughly the same age. This is exactly what we see for elliptical type galaxies. So elliptical galaxies have a fast star formation rate. We can actually see this play out as we look at the star formation history of these different types of galaxies. So in this graph, up and down, we're looking at the star birth rate, how many stars are born each year, and then along the bottom, we're looking at different years. So here's very early on, and out here is kind of the present-day universe. This orange one that we see over here at the beginning, this is what we see for a typical elliptical galaxy. We had a huge rush of star formation early on, and then it burned through all this interstellar medium, and nothing has happened since that time. The blue, closer down to the bottom, is what we see for a spiral. A spiral did have more star formation early on, but not nearly as much as what we see for an elliptical, and because of that, it still has interstellar medium and has been able to continue the star formation, although it has been declining. Now, one other possibility for how to form an elliptical is actually through galactic mergers. So when they first collide, we're going to get an irregular galaxy. However, over time, as they settle down, the most likely end result is going to be an elliptical galaxy. We actually have evidence for this as we look at rich galaxy clusters. So again, remember, rich clusters are these ones that contain thousands of galaxies. When we look at rich galaxy clusters that are around 4 billion years away from us, meaning we see them as they used to be 4 billion years ago, about 30% of the galaxies in these rich clusters are spirals. But when we look at nearby rich galaxy clusters, the ones that we see almost right now, only about 5% of these are still spirals. What has made the difference is that we've had a lot of collisions in that 4 billion years. And as these spirals collide, the most likely end result is an elliptical galaxy. Here is our fourth lecture quiz question. What is the most likely end result of a galaxy merger? A spiral galaxy, B, an irregular galaxy, C, an elliptical galaxy, or D, galaxies can't merge. Go ahead and think about it, and we'll discuss in just a bit. Alright, we just went through this. What's the most likely end result of a galaxy merger? It is C, an elliptical galaxy. So when the galaxies first collide, we get weird, crazy disruptions leading to an irregular. However, over time, as gravity continues to pull on it and they settle down into a single galaxy, it's most likely to turn into an elliptical. So again, the correct answer is C.